Hey there, and welcome. Ever stop to think about why some things happen in the blink of an eye, while others seem to take forever? What actually controls the speed of a reaction?
They're both chemical reactions, right? So what gives? Why do they run on such completely different clocks? From the super fast and explosive to the incredibly slow. Well, it turns out the answer begins with this one really powerful idea that pretty much explains everything. It's called the collision theory, and you can think of it as the master rulebook for how fast reactions go.
It says that for any chemical reaction to happen, the tiny particles involved, the atoms and molecules, they have to literally bump into each other. The collision has to be an effective one. So, what makes a collision effective? It comes down to two absolute must-haves. First, the particles need to smash together with enough energy. It's kind of like a karate chop, right? A little tap isn't going to break a board. You need to hit it with enough force. In chemistry, we call that minimum force the activation energy. And second, they have to hit each other in exactly the right way with the perfect alignment to actually break their old bonds and form new ones.
Well, it turns out we have four main control knobs we can turn to either speed a reaction up or slow it way down.
First up, we have knob number 1. When things are cold, particles are sluggish. They move slowly. But when you heat them up, they get a ton of energy and start zipping all over the place like crazy. And that's exactly why heating things up makes reactions faster. For one, these speedy particles are going to collide way more often. But here's the real key. The collisions they have are much more powerful. A whole lot more of them now have enough energy to blast right through that activation energy barrier. And the end result? A higher frequency of effective collisions. Let's turn to our second knob, concentration. This is all about how crowded the space is. If you have a low concentration, it's like a party with only a few people in a giant room, lots of space. But a high concentration? That's a sold-out concert. Everybody is packed in, shoulder to shoulder. And you can probably see where this is going. When you pack more particles into the same area, they're just going to run into each other more. More collisions mean more chances for one of those collisions to be a successful one. Now for our third knob. This one is super important when you're reacting a solid. Picture a big solid log on a fire. It burns, but kind of slowly. Now what if you took that same log and ground it into fine sawdust? If you toss that sawdust in the air near a flame, you'd get a massive fireball. Why? Because you've just exposed way more particles to the air. So by breaking a solid up, you're creating tons of new surfaces where a reaction can happen. More places for contact means more collisions are possible every second, which, you know the drill, leads to a faster reaction. Last but not least, for reactions that involve gases, we have our fourth knob, pressure. At low pressure, gas particles are just chilling, spread way out with tons of space. But when you crank up the pressure, you're essentially taking all those same particles and squeezing them into a much smaller box. Really, this is just like concentration, but for gases. You're forcing the particles closer together, so they have no choice but to collide more frequently. And once again, what's the outcome? A higher frequency of those all-important effective collisions, and a much faster reaction. So what's the big takeaway from all of this? See, it really does all come back to that one core idea, collision theory. The secret to changing a reaction's speed is all about increasing the number of successful, effective collisions that happen every single second. And now you know the 4 big knobs you can turn to do it. Just crank up the temperature, boost the concentration, increase the surface area, or raise the pressure.